Radar, radio detection and ranging. Radar is an object detection systems that uses radio waves to determine range, angle, and velocity of objects. It can be used to detect aircraft, ships, say spacecraft, guided missiles, motor vehicles, weather information systems, and terrain. Radar was developed secretly for military use by several nations in the period before and during World War II. Modern uses. There are many modern uses of radar, including air and terrestrial traffic control, radar astronomy, air defense systems, anti missile systems, marine radars to locate landmarks and other ships. High tech radar systems are associated with digital processing, machine learning, and are capable of extracting useful information from very high noise levels. Principle. The principle behind the radar is a radar system has a transmitter that emits radio waves called radar signals in predetermined directions. When these come into contact with an object, they are usually reflected or scattered in many directions. Radar signals are reflected especially well by materials of considerable electrical conductivity, especially most metals, by seawater, and by wet ground. Some of these make the use of radar altimeters possible. The radar signals that are reflected back towards the transmitter are the desirable ones that make radar work. If the object is moving either toward or away from the transmitter, there is a slight equivalent change in the frequency of the radio waves caused by the Doppler effect. Polarization. In all electromagnetic radiation, the electric field is perpendicular to the direction of propagation, and the electric field direction is called the polarization direction of the wave. For a transmitted radio signal, the polarization can be controlled to yield different effects. Radars use horizontal, vertical, linear, and circular polarizations to detect different types of reflections. For example, circular polarization is used to minimize the interference caused by rain. Linear polarization, on the other side, usually indicates metal surfaces. Random polarization returns usually indicate a fractal surface, such as rocks or soil, and are used by navigation radars. The frequency range of radar signals is approximately 10 power 3 hertz to 10 hertz, mostly in the range of megahertz. Function. Normal radar functions. Range detection from pulse delay, velocity detection from Doppler and frequency shift, angular direction detection from antenna pointing, singular analysis and inverse scattering applications. Target size from magnitude of return, target shape and components, return as a function of direction, moving parts, modulation of the return, material composition can also be found using radars. The complexity, cost, and size of the radar increases with the extent of the function that the radar performs. And radars are of mainly two types, military radars and civilian radars. Now we are going to see about military radars in Indian Army. Indian Doppler radar. The Indian Doppler radar, INDRA, series of 2D radar were developed by India's Defence Research and Development Organization DRDO for the Army and Air Force. The Indra 1 is mobile surveillance radar for low-level target detection, while the Indra 2 is for ground control interception of targets. Indra 1. Indra 1 is a 2D mobile surveillance radar for low-level target detection. The radar is housed in two-wheeled vehicles. Indra 2. It is an variant of Indra radar for Ground control interception of targets. The radar uses pulse compression for detection of the low flying aircraft in heavy ground clutter with high range resolution and ECCM capabilities. 7 Indra 2s have been ordered by the Indian Air Force. In this slide, we see how a general radar work. Weapon location radar system configuration. And here we see a vehicle, radar sensor vehicle, and a power source come byte vehicle. And there is a power transfer between those two. And the detection is done through a computer using FOC. Advantages of military radars: all weather day and night capability, multiple target handling and engagement capability, short and fast reaction time between target reaction and ready to fire moment, easy to operate and hence low manning requirements and stress reduction under severe condition, highly mobile system to be used in all kind of terrain. Disadvantages: time. Radar can take up to 2 seconds to lock on. Radar has wide beam spread, cannot track if deceleration is greater than 1 mph per second. Large targets close to radar can saturate receiver. Handheld modulation can falsify readings. Types of Indra radar: battlefield surveillance radar, short range, low level lightweight radar, 3D low level lightweight radar, pulse compression Doppler radar, 3D surveillance radar for Air Force. These are the different pictures. This is the schematic of extravision radar, which can have many functions such as weather detection, air targets, RS and ISAR, sea surface targets, and in submarines. Multifunction flight radar. The references. Thank you.